Hello and welcome to the lecture for part 1 of chapter 21. I think you'll like this chapter especially better than the last chapter for two reasons. One, I think the topic here is you're going to find it to be a bit more intuitive. And second, I think you're going to find the topic to be very useful. So what studying cost behavior allows us to do is make predictions about the future that can lead to better decisions. So if you're going to be an accountant, it definitely helps to be able to do these kinds of processes. But then secondly, if you're going to be a manager, which many of you will be, it's going to help you understand what you can ask of accountants to help you make good decisions. So in this part, I'm going to talk primarily about cost behavior. And then in the further parts of this chapter's lecture, I'll talk about cost volume profit relationships, mathematical and graphical approaches to those. But the first part here, I'm really going to get into what cost behavior is. So cost behavior is the way in which costs change as relative or related activity levels change. And related activity levels would be non-financial measures like parts produced, miles driven, hours worked. Those kinds of activities are what we're going to say drive costs. So we want to pick the right activity that really has an impact on driving a particular cost. So as an example, if I wanted to look at, a very simple example, if I wanted to look at fuel cost for my company's fleet of trucks, well, the obvious activity is going to be miles driven. So if I can measure how much gas they used for different levels of driving, I can make some predictions about what future fuel costs might be under different levels of driving. We also need to look at these costs over a relevant range. So kind of the range of expected activity versus all ranges of activity. And I'll talk about that a little bit more when I talk about fixed costs. So the main benefit here is knowing how costs change is going to help us predict outcomes, which of course can lead to better decisions. So the first type of cost behavior, I'll talk about three different types. The first type is variable cost. So those change in lockstep with the activity changes. So as an example, if I wanted to know what my total food cost would be in a hospital for making food for patients, the activity level might be the number of patients that are admitted overnight. So if and maybe the cost is $5 per meal. So if I admit one patient, the cost is $5 per meal, the total cost. If I admit 100 patients, the total cost is $500. So in that case, the cost per unit or per meal stays the same, or the cost per admitted patient overnight stays the same, but the total cost goes up as the activity level goes up. So the graph on the left shows what the total cost would be. So in this case, it's units produced, a particular model. So in that case, if I produce 0 units, my variable cost in total is 0. Whereas if I produce 30,000 units, my total cost for variable cost is $300,000. So good examples of variable costs in a manufacturing environment are direct material. The more products we produce, the more direct material we consume, and it's a one-to-one relationship, and direct labor. So the more units I produce, the more labor hours I need, the more labor cost I have. The graph on the right shows the unit variable cost, and you can see in this case, in this simple example, it's $10 per unit regardless of the number of units produced. Okay. So some examples of variable cost at our school, my salary is a variable cost. The more students there are, the more classes are being taught, the more they have to pay for salaries in total. Okay, so that's a direct correlation. For airlines, it could be the fuel they consume. I already mentioned direct materials for manufacturing, and you can see the other examples there of different types of wages that would change relative to different kinds of activity levels in those companies. So on the other end of the spectrum, if variable costs change directly with changes in the activity, fixed costs stay the same regardless of changes in the activity base. And here's where that relevant range comes into play. So if I wanted to look at fixed cost, maybe a good fixed cost might be, I don't know, uh, rent for the buildings on our college campus. Now that's kind of a bad example because they're not rented buildings, but let's just assume they were. So if the relevant range is 4,000 to 6,000 students, the rent is the same for the buildings on campus. Doesn't matter if we have 4,000 or 6,000, the rent is the same. Now, if we say, what if we had 20,000 students? Well, now it's going to change because we don't have enough room for all of them in that particular set. So fixed costs remain fixed over the relevant range. So in this case, the cost per unit decreases as the activity level increases because I'm spreading a fixed amount of money over more activity. By the same token, the total cost stays the same for all levels of activity, like I mentioned. So this graph is reversed. So on the left side here, the total fixed cost, in this case it's a supervisor salary, regardless of how many units produced, that person gets $75,000 a year. It doesn't matter. When I look at it on a unit, I would actually make that more of a diagonal line. The costs go down because I'm spreading that $75,000 over more and more pieces. So the more pieces we make, on a per unit basis, the fixed cost goes down. So some examples of fixed costs, we could say depreciation instead of rent, but depreciation would be fixed. It doesn't change versus how much activity level there is. Same thing with airlines. The depreciation on the plane itself is fixed. And a lot of salaries or in different kinds of businesses don't really change relative to the activity level. So that's variable and fixed. That's pretty straightforward. Variable changes with levels of activity. Fixed remains the same in total for various levels of activity. But then we're also going to have some type of costs that are fixed or mixed costs that have some of both elements in them. So a good example of that might be, and there's an example there about a rented machine, but another example might be utility costs for a factory. So the electrical bill that we get for the business. So maybe we keep a couple of lights on for security and we keep the building heated with electric heat at a certain temperature to kind of preserve everything. And so if we make 0 parts, we're still going to have an electrical bill. There's still going to be some level of electricity consumed even when we don't make anything. Of course, as we fire up all the machines and start making a lot of parts, the electrical cost goes up. So there's an element of the cost that is variable. There's an element of the cost that's fixed, and we need to break those two components apart so we can say, well, what would our electrical bill be if we made 10,000 parts or if we made 100,000 parts? We could make those estimations, but first we have to separate out the fixed portion from the variable portion. So the way we do that is called the high-low method. So the high-low method is going to say, I'm going to look at a bunch of different costs for different points of production, different levels of production, and I'm going to look at the difference in cost relative to the difference in units produced to get the slope of the line. And then I can take for any of those points the total cost and subtract out the calculated variable cost. That will give me the fixed component. Graphically, that looks like this. So in this case, their fixed costs are $15,000 between no production and 10,000 machine hours. And then once it gets over 10,000 machine hours, it starts going up. Okay, so we have more costs the more we produce, but at any level, it's always 15,000 plus the variable cost here. So here's an example where I've got some units produced and I've got some variable or some mixed costs there. Okay, so I want to take the high number of units. In that case, it's 2,100 units that occurred in August, and I want to take the low number of units. That's 750. And this is really important. A lot of students mess up on this point. I want to look at the cost associated with those 2 points. So I don't want the high cost and the low cost, although that is the case here. It doesn't necessarily always the case. So I want to take the cost associated with the high units and the cost associated with the low units and look at the difference there. So 61,500 minus 41,250, that's $20,250. That's the change in cost between those 2 points. Think of on that graph as the change in the vertical distance of the line. Then I can look at the units produced. So 2100 minus 750, that's 1350 units. So the slope of that line is 20,250 divided by 1350, or $15 a unit. So each unit I make in addition should add $15 in cost. Okay, so an example, 2100 units were 61,500. If I did 2101, it would be $61,515. It would go up by $15 for each one I make. So now I can plug that back into either of the 2 points to figure out the fixed portion. So the total cost is always going to equal the variable cost per unit times the units produced plus the fixed cost. So I can rearrange that formula to get fixed costs by itself. So I show it for both points, although you can see you get the same answer. So for the high level, the 2100 units, that data point, the fixed cost total cost are 61,500 minus the variable, which we just calculated at $15 per unit times 2100 units. So my total variable portion of the cost at 2100 units is 31,500. I take that away from the total. The fixed portion must be 30,000. Now I do the same thing for, I don't have to, but just to prove my point, I can do the same thing for the lowest level, where I take the total cost at that level of 41,250, I subtract the variable cost at that level, 15 times now 750 units, I get 41,250 minus 11,250, that's 30,000. So basically, if you think of all of those points on the last chart there being kind of a scatter graph, I'm drawing a line that's the best fit between those based on the high unit and the low units. So again, now I have an equation. Total cost equals $15, that's my variable cost per unit, times the number of units produced, plus $30,000. So now I can take any number of units. As an example, let's just pick a number out of the air. Let's say, what would the cost be at 2,000 units? So at 2,000 units, it would be 15 times 2,000, which is $30,000, plus $30,000 in fixed cost. So my total mixed cost in this case would be $60,000 at a level of 2,000. I can do that for any number I want to be able to predict that. So I'll post a video practice for a problem that'll be similar to one of your homework problems on Tuesday. So I'll post that, so please do look for that. I think you'll find it helpful. And I'll talk to you again in the next part of the lecture for this chapter.